Good evening, dear participants. Welcome again to this Sunday session of machine learning with Dr. Salman. And Dr. Salman has already joined. So we will be teaching machine learning today and tomorrow. So over to you, sir.
Good morning to all of you. So I hope whatever we have talked today, tomorrow, I'm sorry, whatever we have talked yesterday is much easier for you. And if you must have any query, you must have mailed me. So I think I didn't get any mail. Check it again. I'm sure I didn't get. Yesterday night I checked, I didn't get any mail, but let me check again if I. Yeah, I didn't get any mail regarding the any query. So that means I am much more clear whatever we have talked yesterday. So now we will continue from whatever we have discussed. So yesterday we have first created a data set. Even actually we have downloaded a data set from this. Then we have done the data set partition. I mean, we have evaluated our data set. We have tried to figure out how our data set looks alike by different methods. First by just knowing their head, just knowing their descriptions, and then with some univariate and multivariate plot. So that has been done, but it's a very small data set. So the feature selection is not the part of this, although it's just a one step. So maybe in the regression data set, we will see to the feature selection. So that will be the same here. Now, today, what we will do, we will continue the exercise, and first, whatever the data set we have, we will first split it into the training and testing. So splitting could be on your choice, on your decision. So in the machine learning, at few crucial step, it's up to the user how he choose to develop the model. So first we will split the data set, and then we will try to build up few models, maybe 4 to 5 or even 6. I'll try, but there are so many classification models, but we'll try to do the maximum models. And then we will build up the models, and then on our validation data set, we will evaluate which model is actually performing best. And then we'll try to plot some graph to see how we could represent our data, and that will be enough for a general understanding, or even an intermediate level of understanding of a machine learning project. So okay, so let me share my screen first. So I hope my screen is visible to all of you.
Yes, Salman.
Okay. So if you haven't opened this, so you have to open it, and if you have shut down your system or something like that, you have to open the Jupyter, and you have to this restart the kernel, so that each step will automatically be executed. So whatever the time it has taken yesterday, it will take the same time, but it's not a big data, so all the steps will be done within 2 to 3 minutes. So if you haven't done it, you have to open whatever you have done yesterday, and you have to restart your kernel. So it will execute all the steps. So now
Oman sir, I don't know. Oman sir.
Yeah.
I don't know. Your voice is breaking on my internet. I don't know what about others, because sometimes your voice is breaking. I don't know. It's maybe my internet. I don't know. So
Hello. Is it?
His voice is coming, sir, but sometimes like breaking in your voice.
Okay. Yeah. So
it's perfect.
Maybe internet. It may be internet issue. Yeah. So yesterday we just have checked how to import few libraries, which is essential. That is, I'm just giving a very brief 2 to 3 minutes, whatever we have done yesterday. Then we have imported pandas, matplotlib, numpy, sklearn, which is a specific machine learning package built in the Python language, and then scipy. And we have seen whatever version we are actually using. So whatever version we are actually using, we have checked it. Then we have loaded the sklearn dataset, which is an Iris standard dataset for the machine learning practice. So that could be download from the sklearn dataset also, or it could be taken from a URL, and you have to just make sure to give the column name as well as to make sure that to give the column names and other things. So this step we have done. Then we have just tried to look at the shape of the data set. So this step is very common if you are dealing with multiple data set and it's a kind of a big, you don't know about that. So you have to do these steps. You can check about the dataset by these few commands, how to buy this dataset shape, dataset.head, dataset describe, and dataset distribution. You could classify, you could group by your dataset by size. So these are few commands which is useful when in the future you will deal with some unknown datasets about which you don't know exactly from which source it is coming. So most of the time it happens. So you could know about the dataset more deeply by these commands. And then I just try to visualize, or how could we visualize whatever the data we have. So for that, we have used the matplotlib library. So in the data visualization, I have talked about two kind of visualization. One is univariative and another is multivariative. In the univariative, we have shown about the histogram as well as this box and whisker plot. And in the multivariative plot, it's obviously we have seen how we could analyze our data by means of scatter plot. Okay, so this we have done yesterday. So now the next step is we are going to make you would know we are going to split actually our data set. So that will be the next step. So split out validation data. Okay, so this we are going to do today. So for splitting, first, whatever the data set you have, whatever the values you have, actually you have to take it into some array. So if I just show here once again, so it is just for remind. So we have this as a data set. So our data set contains this column names also, as well as this index also, but we don't need this class, we don't need this headers, we just need these values. So for this we have to take this into an array. So for this we will just type array, and then in the array we just want data set values. So it will be data set dot values. Yeah, it's values, data set values. So this we are going to take into an array. Then if I just have this step, you will see what is in the array. So this is okay. So now you could say that we have taken each values as well as the class, because we have to label it in the supervised learning. So it comes into the array. So now we are going to make them onto X and Y. So X is something by which it is going to learn X are those parameter which is going to learn by the machine learning, which is going to learn by the computer. And Y is something what we want to predict. So we want to predict the class. This is it's come from which class. This is Y, and these values are actually X. We have to define what is X and what is Y. So in the X, what we are going to take as from the array, we are going to take all the rows, and from array we are going to take all the rows. And so for this, the syntax is something like this. So you don't have to worry. Once you will doing much more Python programming, you will learn about these syntax and other things. So whenever we type something into this, so the first thing is about the rows and column. So we have taken all the rows into X, I mean all the rows, and for the Y we just want from 0, 1, 2, 2 to 4. Okay, so we just going to take all this into and once you will type the Y, you are going to take array and then all the columns, but only the fourth one. Okay, so let's see what comes into this. So if I just type X, you see this only this has been comes into the X, so only the values. And if I type Y, you could see this only the class has come here. So only this has comes here. Okay, so this is X and Y. Name error is coming. So yeah, so maybe I don't know what the name error where it is coming. So I'll type first. I'm explaining each step. So it is actually the one step only. So but for much clarification, I am actually giving the result at the each step. But once this step will be completed, I will type this onto the chat box. Then you could see what the results it is actually coming. So now we have divided this into X and Y. And the next thing we want to do is we are going to select this into X train, X validation, Y train, and other stuff. So this is something like X train. X train, X validation, or you could say X test also, you could say this, and then Y train and Y validation, obviously Y train and Y validation, and then you are going to give the command. It should use a train test split, which is train. Let me check the syntax. Train test split. Okay, let me copy this from my notebook. Okay, so train test script. So there is something name error. Okay, I have not called actually one library from what I call from X.
I think validation.
So I have not. Yeah, I missed something. I missed the train test split library from from scikit. I have to call it. So let me call it. I just want to check the syntax of calling that particular library. Okay. These are few libraries what I need to call first. Okay, so let me explain this libraries first. So we have already done with this sklearn. We have already called. Yeah, I'll share the script. So from sklearn.model.selection import train test split. So first we have to call this, and once we are going to select the model, we have to check the cross validation score as well as stratified fold classification report. So these are some of the sub libraries from this library, and these are the models which we are going to use, like logistic regression, decision tree classifier, k neighbors, linear discriminant, Gaussian, and BSTC. So once each step will come, I will explain this. So first let me call this library. So it will take some time. So meanwhile, you could also call it. So I'm just sharing on the chat box. So you could also call these steps. Okay. Now the next step is what I have pasted here is, let me again paste it in the next column. So now this train test split has been actually called. It is a sub library from the sklearn. What it will do, it will split your data set. Train test split, it's a function from this model selection sub library from the sklearn. So what it will do, it will split your X data as well as Y, both data, on a test size. So 0.20 means here the test data or the validation data will be of 20%. So it depends on you what you are choosing. if your data set is very less, so sometimes you choose it by as a 67% and 37%, or if the data set numbers are big enough, if you have big enough number for the validation, at least 5 should be there in the validation. So if you have that number enough, so you generally choose the 80-20 ratio. So it depends on you what you are choosing. So here we are going with the test size of 20%. That means 80-20. And this random states is something which is not obligatory. You just type 1, you could give any number. You could give any number, so that each time whenever you will run your script, so from the random state, so let's suppose here I have given the 1 number. So if it has taken the first row into the first training, so if you have given the same number again, so again that first row will be in the training, and the 5th row or 6th row, whatever it has taken in the test site. So that's why we just define this random state, so that each time we are running the script, it will split the data as it has done on previously. Okay, so now it has been executed. So this will be your command for making a data set into X and Y as well as splitting. So I have typed that command. Is it for everyone or is it for someone specific? No, it's for everyone. So I have typed it. So you could check the X and Y. I have already shown you. So when I'm checking the X, it just contains the values. So for the Y, or you could say the features. For the Y, it just contains what you want to predict. And let's suppose I just want for the X train. So you will see that it has 80%. That means among the 150, 80% is something 120. So the number should be around 120 for this array. Okay. So actually it is not here. So if I type this this command as a print head size of my X data. So let me just copy that command. So you will see what I might mean here. Print X train dot shape. So you see that it's 120. So that means 80% into the X training. X training is 80%, and in the validation data, it's something like 20%. So that means it should be around 30. It should be exactly 30. So you will see the validation shape is 30. And if I type the Y validation, that means it's 30 by 1. It should be 30 by Y validation. What? Oh, so this is Y validation. Okay, it's 30. Okay, so I have done one error here. I have taken Y as a small and here as a capital. Okay, so this is my error. I think no, it's not error. It's fine. Yeah, it's fine. But actually, the standard way is that if you are typing this as I mean, you should take everything as in the same way. But I have given some caps lock thing maybe. So that's not the standard way. So let me again confirm from my script. That's fine. Yeah, it's fine. No, there is no error. Yeah, it's fine. So in the Y validation, actually here I have taken exactly right Y. So you could see that it has taken 30. So and for X validation, we have already seen that it's 30 by 4. You could see there's 30 by 4, or if you want to see exactly what the data is coming here, it's something like that. So you could play around whatever the values it is coming. So we have split it into the 80-20. So at each step you should. So X train actually yeah, X should be the capital thing I have told. So someone has commented in the box, X train is not defined. So just look at this whether you have defined X train as capital or small. So that will be the error. So this is the standard way. I mean, in the machine learning, whenever you will get some scripts, so they generally code. There are some unusual or the coming through. This is just some unsaid rule that each time they just X as capital and Y as a small. So, but it depends. You could choose the capital also, but you have to make sure that here also you are doing in the same way. So now we have already splitted our data set. We could check whatever the values is coming into the X train, X validation, Y train, Y validation. And please be remember, whenever you are doing this into the future, at this step, make sure to check your data, what you actually thought, what you actually plan to do. Exactly the same data is coming into your training or validation or not. Because if it's not going to the same way, so whatever algorithm you are making, your theory may fail. So this is a very crucial step. You should always check at what you have planned to split your data accordingly. It should be the same thing. Okay. So now the next step is, once we have done it, we are going to build some algorithm. So I'm just going to delete these, so that will be easy. So now next step is sorry, you have to go to build the model. So so for building the model, in the classification, there are two standard way. Actually, you do the k-fold cross validation. So for the k-fold cross validation means that you choose some numbers. So the most standard are 5-fold and 10-fold cross validation. But as I said, it depends on your query. It depends on your thought. It depends on your data set, what you have. I have seen some paper where the guys have just done 3-fold cross validation because they have some limited data, some limited sequencing data. They don't have much. So they have done 3-fold cross validation also. But in the field of bioinformatics, but mostly if you go to the textbook, you will get only the 5-fold and 10-fold cross validation. So what does this mean about this 5-fold and 10-fold cross validation means? So that means let's suppose I have a data which has 100 values. I'm just giving an attribute number, 100 values. So if I am taking as a 4-fold cross validation, or let's suppose I'm taking as a 9-fold cross validation. So what it will do, it will split the data set into 10 pieces. So that means now each sub piece has 10 values. So each sub piece has 10 data, and it will train whatever the query we have given on the 9 data set. That means it will train the data on 90 and then test it on the remaining 10. So for the second repeated step, what it will do, so the first 10 set which has been on the testing, now it will come into the training, and then again remaining 90 will be the testing, and sorry, training, and this next one is training. So if I say something like 1 to 10 values, so it will take like, if first is the testing, so 2 to 10 will be the training. Then what we'll do, second will be the testing, then first, and 3 to 10 will be the training. And if we are taking 3, so 3 will be the testing, and first 2 and 4th to 10th will be the training. So that means each time it will make one data for testing, and the remaining 9 set for validation. And this stuff will be done till now, until and unless each data point comes into training and testing as well. So it will not leave any data. So until unless your each data has comes into this circumstances, till that the cycle will go on. So that's why you choose, you want to split your data for the 5, or you want to split your data for the 10. It depends on your computational power. It depends on your data set size. It depends on how much time you have, how much time you want to execute it. So it depends on many circumstances what you are going to do. So, but this iris is a very standard data set, very minimal. We don't need so much computational power as well as time. So we are going to do it with a 10-fold cross validation. So that's always the best if you have equipment and other things to do. So because the data has been trained on multiple data sets, and it has been 10 iterations values. So that means it has the ability to predict much better, because it has been trained with much efficiency. Is my screen is shared? No. Yeah. Yes. So I'm just going to write down what will be the steps. So let me type it again, because I'll type. once there may be error. So spot check algorithm. So first I have called a function as a models. Okay, in the model, so this is some step, some coding with 10 to 15 lines. So that's why I just have pasted it once, because if I'll type it one by one, it will take too much time. So what we have done, we have called the model function. So we are appending some models. So I have chosen 6 models. One is logistic regression, that is multi-class, linear discrimination analysis, k-neighbor classifier, decision tree classifier, Gaussian NB, as well as SVM, support vector machine. So this we have called. Okay. So next we are, I'm going to, let me execute this first. So if I type models, let's see what is actually coming. So you could see that each model has been called. Okay, so in the models, we see that each model has been called. So this will be your script for calling the models. So this is coming from scikit library. So that's why scikit is very easy to go, and most of the people are using the scikit instead of using the Weka and other things. In the Weka, this takes much more crucial steps, much more depth steps, and it's not easy into that. So we have called all the models, and you could see this all model has been called here in the models. So now we are going to run these steps. So we will call it 2 steps, results as well as names, 2 functions. Results and name. Okay. So if you are coding the Python and you are using some IDE like Jupyter or PyCharm or something, so this iteration doesn't have any change in the output. But if you are doing the Python coding directly on the terminal or in some notepad or something, so you have to take care of this iteration. Then this iteration is very crucial. If you have change some iteration or some gap here, so that syntax will be totally changed. But in these IDs, so that's why you always see most of the guys are using these IDs, so we don't have to worry about this spacing and other things. But if you are directly coding, so if you see some advanced coders, they always code in the directly into the terminal, so because they are habitual of doing this spacing and other things. So that's a crucial step in doing spacing these things. So let me explain each step what we have said here. So we have called 2 functions. We have opened 2 functions, results and names. So models we have already called. So now what it will do, it will start this names, and in each name it will take one model from the models. So we have 6. So each time one will be called. So this is, you could say, for loop. So in this 4-line code, it will do all the things whatever we need. So it will call one by one models. So then we have specified what we are going to use. We are going to use k-fold cross validation. So in the k-fold, so that is stratified k-fold. So what we want to do.
Hello.
Yeah.
So actually, like you're talking about the model dot appendage. So that is in bracket, like logistic regression. Start term is name is given LR. So it is defined by the automatics. I have to call the LR only.
It's automatic in the scikit. Yeah.
So we can't define by like own by own. No.
I don't think so. I have to check your query, but mostly it has been defined, and you will see this gamma option and other things. So you will always see, if I just type is tab option, so you will get what you want.
Okay, this is okay, sir. The gamma wala option is okay, but I was thinking like what is gamma, because LR is like a short term name. LDA like
I have to check we can do it with some others or not. But
Yeah.
I think logically I have not actually tested it, but logically you could change it. So in the result you will get some whatever you have called here. So maybe when we are calling LR, so these function what we are calling multi-class, and this may not come. I have to check it. Your question query is good. I have not done it. I have to check it, but logically you could change it. But if you are not giving some other functions, so I have to see actually.
Okay, thank you.
Yeah. So that means for name, the general ruling is that it is the same given in the scikit. So people used to call it like this only SVM. I mean, you will write in the manuscript also SVM random forest and things. So k-fold, all the number of split will be 10. Here I have defined random state. Again, this is, you could choose any number. You could choose 1, you could choose 2, 42, 45, whatever you want. It's just that each time you execute your program, it will split or other things. It will in the same manner what we have done into the previously. So each time we want to shuffle the data. Obviously, we want to shuffle the data. So 2. Then we are going to whatever is coming into this, we are going to write down in the CV result. So cross validation score we have called initially. You could see when I have called some values. So from the scale and model selection, we have called this cross validation score as well as stratified k-fold. Okay, and this accuracy score.
Hello.
Yeah.
Sorry for interrupt again. Actually, maybe some network issues. So, like k-fold, yeah, validation. What he did, sir? What k-fold is called to? What he did actually after fitting the our date model, sir.
Okay, let me check. Let me explain it in much more.
Yeah, k-fold, wala, sir.
So can I know, is there any foreign participant into this? Is there someone who don't understand is Hindi, or everyone is okay? So there are guys. Okay, so let me explain. So what it actually happened, first we have given some data to the machine learning. So forget about the validation data set. What I have done on the splitting into the 80-20. Forget about this. You have something like 100 data. So what it will do, it will automatically split your data into few pieces. It depends on your k-fold what you are giving. Let's suppose I have chosen the number 100. So what it will do, and I have chosen the k-fold as 10 or as 5. So if I'm choosing it as 10, so it will split my data set into 10 pieces. So that means each data set has 10 values. Okay, if I have chosen 10 as a k-fold, if I have chosen k-fold as a 5, so it will split my data set into 5 pieces. That means each data set has 20 values. Now forget about the validation what I have done into the 80-20. I'm just talking about the whole data set. So the machine learning automatically split your data into training and testing depending upon what the k-fold you choose. So it will take 9 data sets, 9 pieces of the data set. It will read the features about this. It will exactly read it and then try to predict what it has taken in the test data set. So each time it will learn from the 9 data set and test on the remaining 1 data set. Each time it will do, and then you will see some accuracy. So your model has already been developed. It has already done, if I'll directly say internal validation, it has done. And then it say, okay, the model has been developed. It already developed on the training data set, automatically checked on the testing data set, and this value is coming. Now, okay, once I have done it, so obviously I'm going to test my model onto the some data which the machine has not seen. So the training splitting what I have done in the first step by 80-20. So that 20 data set has never been exposed to my algorithm. Till now, it has never been exposed to my algorithm. So then whatever the model I have built, it will check on the external validation data set to see, because once we are reading from the internal validation, each time already it has taken one as a test data, but somewhere it has, in some of the step, it was already come into the training, so it knows the feature. So you could say it could be a overfitting or underfitting terms execute. So just to rule out, because sometimes you will see that your internal validation accuracy is very good, even to 90%, 95%, 100%. But when your algorithms come into the real market, when it comes into the real data or the validation data for which it has not been exposed, the algorithms fail because the model has been overfitted. It has seen that, so the algorithms has been failed. So that's why you tune your model for validation, other things. I hope I am clear.
So why need to validation our data? That's my point is again, sir.
Obviously, that's why you want to develop the algorithm. Now you want to predict something. I mean, the overall purpose is something I want to predict. Okay, so because I don't want to do it randomly, so my machine learning will predict automatically. So in another example, if I'll say, okay, so how machine learning goes on. So I'm looking for on the Google for some Apple laptop. So it has trained by my data. It has trained by my data using the same algorithm, and it will try to externally validate. It will try to give me some prediction on some my Facebook suggestions to some new models of the Apple. But sometimes you will feel awkward that sometimes you get the suggestions you have never searched of. You get the suggestions. Everyone get the suggestions you never feel of. So that means when it comes to the validation. So their model, their accuracy is not good enough. Sometimes you get the suggestion. So that's the real life example. So that's why they are continuously improving, so that each time you get some suggestion, it should be precise to your interest. And another way, if I say in the biological example, let me take my example from my PhD. So my aim was to, for the past 30 years, there have been peptide tested experimentally, whether they have been naturally comes from the plant or anywhere, or synthetic peptide, they have been checked for various antibacterial mechanism. So most probably the experimental guys, so the labs actually, they have some peptides. So for one student come and he used to check in on the strepto, I mean some other bacteria, someone else come and he check on some other bacteria, and they used to do it for 2 to 3 years for one particular peptide. So that's why from the last 30 years, I have curated whatever peptide has been tested against mycobacteria. So I have got the data set. So now what I am doing by my so because I don't have some external validation data set, so I just put it some for the validation just to check my data set. So it will take each peptide, it will take their features, whether it's amino acid composition, whether after A comes C or after A comes K, whatever I am giving. So it will read it, it will train their model and try to predict it internally. And then, okay, I'll get, okay, this model is coming 80%, this is 70%, because I have done it for more than 10 to 15 algorithms I have developed. And I will choose the best one based on the internal validation. Then I will execute my problem on the external validation data set. Okay, internally it is fine, it is achieving 80% accuracy. But when it comes to the external validation, it gives accuracy something around 70. Accuracy comes because that data has not been exposed. But if I'm predicting some peptide, some random peptide, if I'm predicting, and it is the possibility that it gives that, okay, this peptide will be effective against mycobacteria with 75% accuracy, there is a still chance that it will fail in 25% when we are going to validate it into the lab. And that has been done. I have designed around 7 to 8 peptides and I have checked into the lab. And initially it was killing mycobacteria, but when I went into the internal, intracellular killing, when I infected raw macrophages and other mechanism involved, so some peptides failed. Just 2 to 3 comes into the picture. So that means from 0 to end, the accuracy is decreasing at each step. Am I clear now?
Yes, sir. Thank you, sir. Lots of thanks, sir.
Yeah. Just validation can be as many times as we want, and it's always better if you have much validation data, diverse validation data. And so it's very important how your validation data looks alike, and that is something if you are dealing only with the dry data, you are dealing only with the public repositories, so that may be the limitation about how you are preparing your validation data set. Yeah, it's always we suffer in because we actually theoretically I want, okay, my validation data set should contain this also, but when I comes into the real world, when I look for that data, I don't get what I want. So I have to limit based on the availability of data. Okay. So I think let me share my screen. So here we have done this k-fold stratified split. I have talked about random state, just so that each time I run the script, it will be the same. And now we are checking this result is actually, you see, is coming on to internal validation. So each time it has done, so model it has taken, so what? So you will see that there is nothing like validation data set. You will see that, okay, it is X train and Y train it has done, and it will check automatically onto this data because it will split this X train. This is 120 into 10. So that means 12 fragments of one data will contain 12 values, and 12 into 10. So that means 81 108 will be for the training and 12 will be for the testing for each time. Then again, that particular 12 will come into training, and another set of 12 will come into the testing. So in this way, it will train and test. So that means at this step, actually, it is making around 10 models. You could say randomly it is making around 10 models for if it is taking, let's suppose if it's taking this LR. So for the LR, at this step it is taking 10 models at different values. Okay, we have chosen the multi-class also. We could give some other options here. So it will automatically increase this. So maybe if this multi-class contains some 5 to 6, so 12 into 5. So you could do this permutation combination, how much model is actually developed at this step. Then you just score it. You just ranked it based on the accuracy, which model is coming. So I'll not take care of about the remaining 10 or remaining 20 model. I'll be just interested into that particular algorithm, that particular model, which has the maximum accuracy on the internal data set for the linear regression. So same step will be done for all these 5, and then I will see which one is the best one. Okay, so now it is just the result. So whatever we are whatever this command will give the output, it is just appending that. So they get so that means each step, whatever the result will be there, so it should be appended into that. Otherwise it will rewrite the first step. So it don't have to rewrite it, it just have to append it. So then again, whatever we are coming the names, it should append. And I'm printing what name from this CV result. So I'm taking the mean as well as standard deviation. I'm just taking this. Yeah, I'll share the whole script with you, because if this is not the standard way to write the script, it is just what the first step is actually you have to understand. I have demonstrated that into the way. When the final script, I'll share with the final script, you will see some of the steps has been written over and some of the steps has been written in the below line. But I have explained you the earlier so that it makes easy. So when the final script I'll share, so you will see that these lines are shuffled, but that's the actual way of writing the script. But if I'll start with that, that will be harder to understand. So that's why I'm just going with one by one step, and then I'll share the whole script. You will get it. You don't have to worry about what. Oh, I think. Yeah. So I just missed this equal sign here. Okay. So now you see, I just have printed here. So you could see whatever, how many it has appended here. I have not, appended the whole result. I just have printed mean. So you could see that the best model has something like 0.94, or you could say 94% accuracy, because it has been CV result has been scored on the basis of accuracy with around 0.06, or yeah, 0.06 into 100 is something around 6% of standard deviation. And then you will see of the LDA, KNN, so some all around 95 to 97, but and this SVM has 98% accuracy with 33% of standard deviation. So this also is a crucial step. What you are going to choose. So this is very the first step. Sometimes we get we don't choose the model based on the accuracy. We choose the model based on the sensitivity, based on the specificity, because it depends what kind of data we are dealing. What is our actual question? If I want to make some true positive more, I'll go with the sensitivity. If I want true false positive, I mean true negative more. So that means let's suppose that I just want to predict that this is a pen. Okay, that means it's a true positive. I want to predict it as a pen. I just want to predict it is not a pen. I don't know what it is. I'm not interested what it is. It could be anything. I just say it's not a pen. So that means it's specificity. You are talking about the negative prediction. So it depends what you are actually asking. So based on to that also you go with the function. So accuracy is the most acceptable and thing in the initial. So I just went through, I just prepared this according to the accuracy. Okay, so this let me paste this into the chat box so that you could also execute it and see what result you are actually getting. Okay, so is there any, I mean, query till now? If is there any doubt till now? You could raise your hand if something is missing till now. Let me check on the CV result. So you could say what it has taken into the CV result. So it is only the last step. So if I've not taken the for loop, so you will see how many will be there. It's just only the last step. Okay, so then it has taken the mean of all the models and the mean model has been developed here. So if you don't take this step, you just want to write it. So you will get a file of something around more than 2 to, I think we have running 6. So 10 into 6, 60 at each step. So maybe around 600 lines file you will get something. Okay, so how can we get class wise accuracy? What do you mean by class wise? I'm not getting what do you mean by class wise accuracy, Rahul sir? It has all, I mean, it has taken onto the all classes, all 0, 1, 2, what we have decided. So I don't understand your question. So now we are going to compare the algorithms with some plots. Okay, so that will be another way to present your result. It's always what you are getting is what you have developed is sometimes less important than how you are going to represent it, because now the guys are much more interested in, yeah.
In the last line of the code, print %s is to % of that line. Can you please explain?
Okay, so I just have printed here. So I have given the float value, and I mean f is something for the float values for the point. So in the name, this is or whatever it is coming into the name. So this name has been written. So you could say this name as this is a string percentages. This is a string. So name is a string. Then it has taken it should write the float value, means it should consider that if I'll not give the dot f, I'll get some error that because this is something having the decimal thing. So you have to define, okay, this value is in the decimal. Then again, I want the standard deviation also in the decimal. So I have given the comma and other things. This is %f. Okay, so this is also float values. So in the name, so what this string is something about the name. That means name of the algorithm we have taken for name models in the model we have already defined here. So the name is built there. Then the second value, which is a float, we are going to take at each step. So once this code has been done, so once this for the first linear regression it has done, so it must have developed. I said now for around 10 to at each step around 100 models have been developed here. So it just take the mean accuracy, mean result. So it has taken the mean. So the best mean is coming at 0.94. So whatever result has been achieved here, it's in the form of array. It takes the mean of that. So this is the mean value, and then from that value, whatever value we have got, it taken the standard deviation. So this is standard deviation. So this is for the first model when this code runs for the first thing. In the second name, we have already called for the LDA model, LDA machine learning algorithm. So then again, the same code execute, it takes the mean and other things, and we got this at all. And in the last, we have called for the SVM. You could see here in the initial previous step, we have lastly called the models SVM. And once you will do it, you will see other options of parameters like alpha, beta, gamma, whatever you want here, auto, other. So here I have taken the auto thing. You could define it. You don't want auto, you could put 1.5 value, 0.6 value, whatever. So you have to define it and you will get the, so here we have taken the SVM call that, so this result has been put here. Okay, so there are two more questions. Based model can be selected based on accuracy only or accuracy plus AUC. Okay, base model. So how can we get class-wise accuracy? I didn't get very low. When does back? Best model can be selected based on accuracy. No, Rucha, it depends on your query. Each time you don't choose. It's not recommended just to choose your model based on just on one parameter. You always try to see the model which has all the parameters are into some values. So like for me, there have been many cases where in one model I'm getting very good accuracy, but it is good for predicting true thing, but not predicting the negative thing. So that means my sensitivity is very good, but my specificity is low. So that means my MCC is also not good, but the accuracy is good enough. It could the condition. So I'm not choose it because, okay, this model is good for predicting the positive thing, but not good for predicting the negative thing. So I'll always go with that model, which is balanced, which, so it's always recommended. Okay, it's not, if it's not predicting this as a pen, okay, say it's not a pen, but it should predict it as a pen. So then it's the best model. So you choose it based on various parameters, based on sensitivity. If it is talking about, we are talking about only the classification based algorithms, it should have good sensitivity, it should have good specificity, it should have good accuracy, as well as you could say AUC is the same thing, but another important coefficient is MCC. So all these four parameters should be balanced to say that your model is good enough. Once you will do project in the machine learning, you will get some papers of the low quality where they just talk about the accuracy. So they don't present other parameters. They just hide those parameters because they are not good. I think last week only I was reviewing a manuscript where they have not shown some other parameters. And when I asked them the query to show that, when in the comments I got, so that's not the good other parameters, so they hide it. So it's not good, but some guys used to prefer, some guys don't used to prefer. So it's up to their conscience as how they want to present their result. Okay, sir, please describe K-fold stratified. Okay, my question from split out validation data set. Y, X and Y. X and Y, just I had just defined my whole data set into X and Y. You could define into Y, Z also. It's up to you. X is something on which it has been training, and Y is something what we have to predict. So you could see the Y is actually labeling as a class, whether it's a positive or whether it is coming from which iris subspecies. That's the Y what you want to predict. And X is the feature on which it has been trained. Please share some details on accuracy for us to refer later. Okay, this I think I have missed. I should I will make a PPT around these parameters. What is sensitivity, specificity, accuracy, MCC, and how it is calculated. So I'll make sure to make a PPT about this, and you will try to speak more about this on tomorrow. So we are already running too late, and it's still what I thought to tell. It's few things left, but it's fine. It's Sunday. I have time. We could extend the session. So CV fold scoring accuracy, we have to, okay, someone has asked to repeat the step. So as I said that it's up to my concise. I have chosen the 10-fold stratified K-fold cross validation. So I am just splitting this into the 10. You could split it into the 5 also. You could split it into 3 also. There have been some studies where they have split into 3. But it's always, if your data gives you the liability to split into the maximum number, it's always better to go with the maximum number. If your data give you the liability, or you have the privilege to split your data into maximum number, it's always go with the 10. So 150 is something good enough, but if you are dealing some sequencing, real-time sequencing data, maybe that is coming from just the 3 samples, so you can't be having the privilege to split it into 5 or 3 when you can't do the 3 splitting. Okay, so that will that's the thing I was talking, but it's a good data, so you could split into the 10. So here I have splitted the data into 10. So what it will do, it will split my whole data set, that is 120, what I have taken into the training, into 10 pieces. That means one data set 1 will contain 12, data set 2 will contain 12, data set 3 will contain 12, and so on. So what it will take in the first run, so data set 1 will be for the testing, internal testing, and remaining 9 data sets will be for training. And in the second step, data set 2 will be for the training, and remaining 9 will be the testing. Similarly, for the third model, so data set 3 will be for training, and the remaining will be testing, and so on. So in this way, it will, already split the data. 1 will be for the training, 1 will be for the testing, and 9 will be for training. So it will extract the features, read the features, and try to build some algorithms, whatever the features are important to predict, and then it will try to predict that onto the remaining data set. So, okay, because we already know that this row is coming from this, we have already defined into the Y train, okay, when the values 5, 4, and 6, and 7, so it is coming from the iris. So then it will match, with the Y, okay. It has the same value, and it is iris, but I have predicted is something else. So based on to that, it will calculate the accuracy, whether it has predicted right or not for each turn, and then it will score the function. So here I have got, so on each run I just have taken the mean, so the mean accuracy for everything is around 94%. So okay, that's what about this k-fold strategy.
Sir, how much accuracy is acceptable?
You will get it something, I mean 50 is something, just I'm betting something, I mean adding the, even if you are if you just go with the coin, it's 50%, so 50 is nothing. So you will get some papers even for the 60%. I have read some papers, I have read papers for the 70%, and even always if you say 100% is overfitting, but 90%, 95% also. So it's not the exact answer, I should say. I mean, most of the papers, something around 70 to 80 you will get. Okay, that's a good enough. You are predicting something with the 70% possibility, or the probability is good enough. It's just guessing, huh? It's just guessing based on some facts. So you could say
so accuracy for what measurement will take? Sensitivity, specificity?
Accuracy will take everything, with the sensitivity also, with the specificity also. I apologize for that. I must have made a PPT for sensitivity, specificity, and I should explain the formula, what it is actually taking. I apologize for that. I should have made that PPT, but tomorrow surely I'll make that PPT, and we will talk about this parameters, how it is been actually calculated. So accuracy take both sensitivity as well as specificity, both.
You are saying sensitivity sometimes like good, and specificity is not good. Then how will measure like this model is good? In that condition,
let me say that let's assume a condition where the sensitivity is around 90% or 95%, but specificity is around 55 or 56. It's possible. It's not hypothetical. It's possible. But when you will calculate the accuracy based on the sensitivity or because one value is around 95 and one value is around 55, so you will always get the accuracy around 74, 75. And if I'll hide sensitivity, specificity with you, and if I'll present you just the accuracy, you will say, okay, it's a good model. It is actually predicting with 74% accuracy, because you are just seeing the accuracy. But in half of the data set, it is just a random guess of around 54%. That is very poor. Even we already failed in some of my projects where I got the specificity something around 40% and sensitivity something around 95%, because my data set is very biased, and I'm getting the accuracy something around 70 when I calculate it. So if I'll hide the specificity, so even in the specificity, it is negative prediction. It's totally opposite, less than 50%, but I'm getting 70% accuracy. So that's not a good model. That is actually making false prediction much more. So okay. So we'll talk about this sensitivity, specificity, accuracy tomorrow. That will be much more clear when I'll make a presentation about this. Okay. And there is one more question, I think. Are we limiting the test data set size and getting good average accuracy finally? If we have more test data, then maybe accuracy will decrease. Yes, Mushadil Islam. Yeah, that's a very logical and very accurate questions. That's why a good algorithm is always accepted when you have validated your model on some good amount of validation data set. Whenever you will communicate some manuscript, they will always talk, okay, it's not coming on the validation data set, don't have the sufficient number of validation data set, try to increase it. This is the problem we bioinformaticians always feel they are not coming with the lab which generate their own data, because we lack data, we use others data, so we already lack. And they and sometimes they say, okay, whatever you have predicting, you just validate it with some other things. So it's always better to have much larger validation data set. So that will be always a question for debate. That's always, you could say, cons of your model. I mean, whenever you develop a model, you always say that if I have much better validation data set, I may have performed, or I may have made some good algorithms. So that's the limiting step, you could say. Can you share a code block as exceeding precision rather than accuracy? Okay, I'll try to share that code. So when you use split, we are using very less validation data, isn't it? No, we are not using less validation data. Actually, we are making it on the 9 sub particular and 10. So we are doing the k full loss validation is good, but the validation data is something we have already defined as a 20% initially, and that hasn't been come into the picture. The external validation has not been come into the picture right now. So doing 10 or 5 will make the internal validation same. Each time the data set will be same 20. Either you take it as a 20 into 1 data set or 10 into 1 data set based on a 100 data, the number will be same. Okay. So let's move on to the next step where I want to compare the algorithm with some graphs. Okay, so I have already called pyplot dot box plot. Let's see. Okay, yeah, let's go with the box plot. Results, and the next I'll take as labels or as the names. Okay, so define labels as taken name. Yeah. So yeah, okay. Algorithm comparison. Okay, python dot show. Okay, what's the error? There is dimension of label X and Y. Dimension of labels and X must be compatible. Okay, let me check. Yeah, so I just have put one name instead of names, and because I have called it as a name, so you have got whatever errors I have got because I've called it as a names. I just put name, so a lot of error was there. Okay, so you could see that in linear regression, the mean is something around 95.95, you could say, and the LDA is comparable to the SVM. This is just one outlier, but the standard deviation, you could say there have been model with 82%. So I'm just taking mean as mean accuracy as the best model. You could say this one and this one is much more comparable. So whatever how many models we have developed here, so the mean is actually around 100%. That is actually 98.33 we are getting, and just one outlier is there. So the rest model. So that means here SVM is actually, it gives the idea here, okay, on this data SVM is performing or outperform some other model, but it is comparable to LDA. That's all. And so when we are going with this, maybe you have already shown this into the Python classes, but okay, if I want to label it and then if I want to modify my graph here, I just want to do this pyplot and then dot titles, that title, do this as algorithm comparison. I go, okay, so I have written. So that means what we have got. So we could represent, or we could, present our data, present our results into, instead of this table, we could present our data in this graphical manner also. Okay, this is some good questions. I'll answer it while discussion. Let me complete few more steps. What I have decided to reach till now. Then I'll go with the chat box. Whatever query we are getting, some good queries I'm getting into the chat box. So we'll discuss it after these steps. Okay, so the next thing is that what I have done it. I'm just going to make prediction. So because okay, model has been developed, so now I'm going to make prediction on the validation data set. Then only our whole exercise will be completed. Predicting the final outcome or predicting the validation data set, or you could say external validation data set. It depends on the query. So you will find few queries for this. Sometimes they just type test data set. Some guys used to say internal validation, external validation. Some guys to prefer testing data as well as validating data. Testing means internal testing, and validating means external data set. So it depends what you are writing. All the things being same. So now what I am just, so I have built several models, but I know that onto this data, the best one is SVM is outperformed others. So just I just choose SVM. So what I have done, okay, I just call the model what SVM, sorry, okay. So for the SVM, I've called it with the SVC gamma. Okay, so this is how we have called. So and the parameters I have taken gamma as an auto. So it's the same parameter I called, and I am fitting. So now finally the model will fit on the X train and Y train. So this will build the final model, and then I'm just predicting my final outcome on the validation data set that has not been exposed to the model till now. It hasn't been exposed till now. It's just going to, the model has been built. So in the X validation, I just have values 5, 6, something. I mean, sepal length, petal length, other things, and it will predict what whether it's come from which species or not. So this has executed actually. So I type prediction. So you will see this. It has predicted like this. And let's check the Y validation. So you see, this is the actual result. So in the Y validation, we have already defined that this doesn't come into the picture. So the first value or the first data is actually iris setosa, and you see it has predicted this as the same thing. Okay, the second one is versicolor, so it has predicted this as the same thing. Similarly here it was same, but it was something, because it's a standard data set, we are getting 98% accuracy, then it's fine. But once you will deal with some other data, like I used to do, I always get, okay, this was a positive peptide, okay, my prediction is positive. This was a positive, or my prediction is negative. This is positive, or my prediction is negative. That's how we, when we see the data, we find it, the differences also. But it's a very good data set. We have 98% accuracy, but so that means all these values are same. So here you could say, based on to the X values, it had predicted the Y value, or the prediction. I have taken the prediction, and this was the actual label. So you could compare it, and based on to this, you will plot the graph and other things. And now next is I'm going to evaluate my prediction. So here are some of the parameters I am evaluating. So let me type this in the chat box. Compare algorithm, I missed it. So that you could. How could we read this array predicted? So yeah, obviously you are not going to read it in the array predicted. Just type some other commands and make it into the Excel format or CSV format. So there is something, you take it array to CSV, and your result will be saved into the Excel thing. So there have been commands. So if I'll talk each step into this will be a never ending workshop. Okay, so definitely you're not going to read the array. You have less data. So you know the command, I'll call it prediction dot CSV or something. I'll call the panda and then take into the p dot what is prediction to CSV or something as like I'll call it. I don't exactly remember the syntax right now. And all my output will be saved into Excel. And this, okay, we have done these steps. So I have pasted the all both the steps in the chat box. Now I'm going to see how my final model is, how my predictions are. So I'll evaluate my predictions. I mean, evaluation of final evaluation or evaluation of prediction. So, okay, so now I'm going to call first index. Okay, so now I'll predict the final accuracy. So initially I was just talking about the internal validation. If you read some papers, you'll see that they used to represent accuracy on the training as well as validating both, just to compare that. So and I'm finally accuracy I'm predicting, I am calculating based on the Y validation. That means whatever the internal, whatever the data, actual data was based on the predictions, and some confusion metric classification report. So this could be different parameters. I mean, it could be recall, precision, sensitivity, specificity. So you just have to define that. You just have to call some statistical library, and that will calculate all the parameters. So here you know that, okay, so the precision for this is 1, but for this value, you could say that the precision is 0.86. I mean, it is getting some difficulty in identifying Virginica, but for the iris vesicular and setosa, it's good. Okay, similarly for the recall and F1 score. So we'll talk about this F1 score, recall and precision. So overall accuracy macro age is 95, 97. So this is what we got. Overall accuracy for the validation data, you see this is 96%. But in the internal validation data or internal testing data, overall accuracy was around 98.33. But in the validation data, external validation data set, the overall accuracy is 96. But still, it is good for the internal testing as well as external testing. So this model is good. Sometimes when you will explore more, you will find that on the internal validation or the internal testing, it's something around 90, but on the external data set, it's completely failed. So sometimes it happens. So I think that's enough for the first machine learning project. Okay, the script you will get by the mail. You'll get the video, and I'll make sure to mail you or the host the final script also. I just have to make some changes, and then the final script will be also made. So let me type this also into your chat box. I think similarly matrix, it's something you just pointed out here. I think similarity matrix. I just have to check the similarity matrix, something. I just have to call it again. Instead of confusion matrix, it's just a syntax. You just have to call it. Just try to look at the syntax. I correctly remember it's like this. There is some other. It's so I have to define the similarity matrix. I have to call it, and then we could do this one until the final result. It's not a big task. Could do it easily. Just have to call whatever the library is actually coming from the similarity matrix. Okay, so that's all from my side about the presentation. So let me go through the chat box, and
Can you please share the code on the chat box?
yeah, you will get the whole code, final code in the mail. Don't worry.
Okay.
Yeah, I'll mail.
We always share the chat box.
Yeah,
Especially
the chat box.
we always share the chat box.
The chat box also, and I'll make a final script with limited lines, and the final script will also be shared with you. Don't worry, you'll get it. Okay, accessing. So when we split, I have talked about this. Accessing labels equals to name. Okay, it is pointed mistake. For our model, if you are getting 80% accuracy on one external validation and 81 on another external, which accuracy we should consider for our built model. So because you are doing it on the external validation, that means you have already selected what model you are. One model you have already selected, and then you are checking onto the validation data set. So in one of my papers, same thing I have done. So I have splitted my validation data set into 2 or 3 kind of validation data set. And then I found accuracy in the range of 80 to 90. So I have reported the mean accuracy. Okay, I have run into the 5 different validation data set, and each is coming this to the final average accuracy or the mean accuracy is something around 84. That's how I have reported. The question, this is the answer for Rucha Badapurkar. Okay. How we could read this array predicted? Khadija, we array predicted, for the array predicted, we have to save our result into some Excel or something. So there are very easy lining. You have to call, you have to take into variable prediction, whatever result you got, then just call it to CSV format or to XLS format, and you will save your result. So I think with similarity matrix, this we have already discussed. Please share some detail to learn more about confusion matrix, etc. Yeah, it's yeah. I mean, yeah, it's good suggestions to detail about confusion matrix, etc. But it's not possible for me to cover each and every detailing about each and every step in 4 sessions or 5 sessions. I mean, it's not possible. You know, I tried to give maximum from scratch to the final, because I know there have been beginners who are doing the first time machine learning. So I try to give from scratch to end, but it's not possible. I could give each term in a very detailing thing. It will be a huge session. I need maybe 2 to 3 month session. I need. Because still I am doing the same thing from 2014. It has been around 8 years, and I'm still learning. I'm still words used to come for which I don't know, stats used to come which I don't know, and I have to go through and I have to learn. So everything is not possible to share. But yeah, if there is some specific query, you could always write down to me, and if I know, I try to answer. If I don't know, that if I have the time frame or time permitted to this, I'll try to different. Obviously, if your query is interesting for me, then obviously I'll try to invest some time into it. Also, how to deal with getting varying accuracy after training the dataset number of time. So where I have called for the mean, you don't have to call for the mean. You just have to change into your code, and you will get the whole result for a whole 100 or something, whatever at each model you have got. So I just have called the mean, so you don't have to call for the mean. Don't take it in the for loop, run it one by one. You will get all the values. So this was just to concise the result. Don't take it into the for loop. Just run it each model each one time, and don't take the mean value. So when you are appending the thing, you will get 10 or 12 accuracy or 12 prediction to that. If there is any specific query, you could unmute yourself, because I've already answered whatever in the chat box. So if there is some specific query, you could unmute yourself and we can talk about it. So I don't think so much.
Sir, actually, I wanted to ask you that whenever means we build a model, we get some accuracy, and again next time means for the best model we get some accuracy, and again for the next time when we again train the model, and then we get different accuracy. So how to deal in with that?
So that's why you always report the mean accuracy.
Okay.
Because you know, if the random state, the number I have given is a 1, just change the number. Just try to play with your code. Instead of random into 1, just take it 2 for the next one. You will see that first time you are getting some 96% accuracy. Next time you may get 96.5 or 95.5 or something like that. Okay, so being not other project, being if you are doing some research project and you are submitting your manuscript, so some good journals, they ask for the code. So they also ask for the code, what you have written, you have to deposit it on some depository. How you have done, how you have written it.
Okay, we have to consider a mean value
Yeah,
always.
because it's something like that. It is just taking the numbers, you know,
Yeah.
big numbers. So always the value will be each time it is the. I mean, it will not be like in the one run. If you change the random state from 1 to 40, it will not be like that from 95 to 70, but it will be like 95 to 94 or 94 to 96. You know,
Yeah.
around that. Always like that.
Okay, sir. Thank you.
Any other query?
I think Salman, most of the questions are, or it's already 1 hour and 20 minutes session. So thanks for today's presentation. You covered beautifully all the important fundamentals of machine learning. And tomorrow we will have again Dr. Salman for some fine tuning of this machine learning module. So I will share the video recording of this session along with the chat as soon as possible. So, and also please go through our programming videos for genome wide association studies module. I have already shared it in the drive link. So kindly go through basics of R programming. These are prerequisite for genome wide association studies. And also kindly spread the word about our next workshop, that is drug discovery and development. Again, it will be a 1 month bioinformatics workshop. So if you are interested, you can register, or you can pass this information to your colleague and friends, so that more and more people get to know about affordable bioinformatics education initiative of Decode Life. People like you support us so that we can provide and affordable education and liberalize the bioinformatics education. So thanks, Dr. Salman, and thanks participants for making this workshop wonderful. We'll again meet tomorrow. With these, I will seek permission of sir for ending
Yeah,
today's
yeah,
session.
honestly. Thank you, everyone. Bye. Have a good evening. Bye.